All right, hello and welcome back. My name is Corey, and we are in the middle of building our own programming language. That is, we're building a custom language using C++, Bison, Flex, Google Test for unit tests, all these. You'd think I'd have that list memorized by now, but oh well. This is the second time that I've recorded this intro because the first time I started showing you stuff and I realized I never changed the screen. So yeah, that happens every once in a while. And so you were just seeing my big face the entire time and you weren't seeing what I was trying to show you. Having said that, let's just switch to that now. We are going to be trying to do two things today. One is, I think, simple. That's adding parentheses. And then the other is going to be slightly more difficult. And that is... sorry, my brain just stopped working. And that is adding typecast operators. Now, as I've said before, I've written this programming language project two different ways before I even attempted to record this. I've done it differently in those two different ways. I tried a tree walker. I wrote a small virtual machine for another one, but I'm not copying and pasting those. I'm starting from scratch. I'm taking a few different approaches. For example, I wasn't using singleton pools before. I wasn't using the garbage collected apparatus. By the way, that's also how I found out that using shared pointers was so slow. And well, okay, that's what you do. That's how you learn these things. Is that you? I'm not saying shared pointers are bad. They have a good place where they can be used, but this is not the right application. So, all right. What we want to do is just have a really quick talk about the order of operations. And let's just open Bison and go down to, we declare our tokens, and then here we have our precedence rules. And these can be confusing. That is, when you start talking about precedence and then what is its associativity, left or right, the problem is that people talk about precedence in different ways, and you have to take into consideration what are they talking about here. So, for example, if I pull up the order of operations page on Wikipedia, and we can go down, and it has a section on order of operations in programming languages, and right here, and it gives us a precedence. And it even says found in many C-style languages, except it even points out, though, however, Python and Ruby have a few things that are in a different order. And one of the nice things is, hey, if you're writing your own language, you can define however you want it to behave. And that's what they did with Python and Ruby. They said, you know what? It says here, Dennis Ritchie says that something should have been done differently in the precedence operations. And so even though C++, Perl, and PHP all implemented in the way that C did, Python and Ruby said, no, we're going to change this around. Okay, great. This is your programming language that you're writing, maybe along with me. You can do whatever you want to. But if we look at the ordering, what does one mean the highest precedence because it's done first, or is it the lowest precedence because it's number one and the stuff at the bottom of the list is highest precedence because it has the highest number? The problem is it's ambiguous. People use highest and lowest precedence to mean different things, and it's always annoyed me. So I've always looked at it as what's done first versus what's done last. And what do I mean by that? Well, an equal sign. If I have the statement A is equal to 1 plus 2, what do I expect to happen? I expect the 1 plus 2 to happen before the equal sign. And if the plus is up here, the equal sign is down there. That means in this list, all the stuff at the top is done before the stuff below it. All right. How does that match up with what we did in Bison? And let's get back down. I want both of these on the same screen. Here we go. In Bison, we're going to be comparing these three rows. Why? Because you see we listed plus and minus first. That's row 4. And by the way, they are. It says it in the prose above this that these are normally left associative. But what is the next in the line? That is multiplication, got that word out, division, and modulo. And notice it's in the reverse order on this list. And then the unary minus, well, that's what this is right here. It even calls it the unary operators, and they are right to left, whereas most of these are left to right. And except assignment, right? They're done right to left. If you say A is equal to B is equal to C, you would expect the farthest right to happen first, and then you would want A and B and C to all have the same value, not A is equal to B happen first, and then it would break on the C equals C. So anyway, all right. So yeah, notice it even says typecasts are on the precedence of the unaries. Makes sense. Okay. So the typecasting, that's the other thing I want to implement today, and I've not done this before. Didn't do it in any of my other languages. I can think of a couple different ways. We're going to choose one way of doing it and get it done today. That's the goal. All right, but first we're going to start off with the easy stuff, and what do I mean by that? The parentheses. And as it turns out, we've got, we're already in the Bison file. Let's just add tokens for this. We will say %token L paren, and it can be that. And I misspelled token, I see that now. And this will be R paren. There we go. Left paren and right paren. So that's easy enough. Yep, let's edit the flex file. And we will add, scroll down. Here we go. And where do I want to put these? I can keep on adding here. Sure, why not? And I bet you we're going to need this to be escaped. So a left paren, and we're going to return a Tang parser, make L paren probably could have copied a lot of that. In fact, we are going to copy and just change this to a right paren, and that should be okay. We will know soon enough. And if I just tell this to start compiling, it should tell us if there's any errors, right? Let's... I've said this every time and I still haven't changed it. We did not get an error. I can scroll up and see where it happened. Generating the Bison up here, generating Bison did not give us any errors, and generating Flex did not give us any errors. Now we need to go back to Bison and add the changes. But let's... what I mean by add the changes, tell it how to recognize a parenthesis. Or the parentheses pair. So we've got integer float, plus, minus, times, divide, %, and the unary minus. We can just keep on adding. We'll go, whoops, that's an or. Left parentheses, expression, right parentheses. Not at, but $2. Now, this may surprise you, but that's all we have to do. What this is doing, remember, this expression and all of these rules, we are defining the grammar, okay? And and in this grammar, we're saying there's a rule that when you see a parenthesis, you should have an expression, a fully formed expression, and then a left parenthesis. But what can this expression be? Well, that goes back up to this pattern, and it could be an integer, or it could be a float, or it could be an expression plus another expression. And since this is a kind of recursively defined thing, Bison, we're not even having to say what the associativity, not associativity, but what the precedence is, because by our design of the grammar, it's going to have that, let me bring back that page, it's going to have to be, say do whatever is in it first. That is the way it's going to form the abstract syntax tree. So that means, and I'll show you that in just a moment when we go to writing our tests. But this is all we've got to do. I'm going to save that and make sure it doesn't give me any errors. All of our tests are compiled. There we go. Now, let's edit the test file, shall we? And we're going to an expression. Let's do parenthesis. Just have to find a place to put it. Parentheses. Parenthesis is either the left one or the right one. It's a single one, but parentheses is the plural. All right, so what we want to do is 3 minus 5 minus 1. And I'm going to put a parenthesis here. And we're going to now have this as 5 minus 1 and put the parenthesis here. First one, 3 minus 5 should give us negative 2. Minus 1 should give us a negative 3. So that's, and now 3 minus 5 minus 1 in parenthesis now should give us a 5 minus 1 is going to be a 4. So 3 minus 4 should give us a negative 1. And it's like, do we need to test all of these? I don't really think so. I want to do things like I want to make sure that none of that causes any problems. A minus 3 minus 5 should still be a negative 8. And by the way, we could even put the negative, whoops. Yeah, want to put the negative there. Put 5 of them, and then 2, 3, 4, 5. Again, that should again just give us a negative 3. And let's go from there. And oh wait, was that our? Okay, I want to break one. Make sure it's correct. Replace that with a 2. Yeah. That is is that all I need to do? Is that the only things I kind of need to test? It's just evidently it's doing the multiple parentheses don't matter because Bison is able to interpret it. And you know what? I said I was going to show you. So let's do cout p1 dot dump bytecode, I think. And oh yeah, semicolon. And we'll do the same thing with the P2 with, there, just putting a line in between them. And for the first one, where it's 3 minus 5 minus 1, notice it pushes a 3, pushes a 5, subtracts them, and that will put the result at the top of the stack, and then pushes a 1 and subtracts them. Whereas the second one, push the 3, the 5, the 1, so the 3's on the stack, the 5's on the stack, and the 1's on the stack, and then do subtract, which will do the 5 minus 1, and it will put its result of 4 on the stack, and then it runs subtract again. So it's acting exactly like I would expect. And by the way, if this kind of thinking is weird to you, when I was in high school, this was way back in the 1900s, the late 1900s, but the 1900s, we actually had calculators that use this type of notation, the idea of a stack-based storage thing, and you didn't need parentheses to do your stuff. And it was, somebody out there will probably know about it, but it was the HP RPN calculator. Yeah. And they're on Amazon. They're probably really expensive. I just want images of them. Yep, that's what they look like. And is there an emulator? This would be interesting. I just want like one online, and I would show you how it worked. HP calculator simulations. This always scares me. Let's see. Can I make this bigger? So to do like 7 times 5, you do 7. You see the 7 up there now? Enter, what did I say, 5? 7 plus 5? 5, and then you would say plus, and that gives you 12. But let's do 7 plus 5 times 2. And where's the clear? There we go. So 7, enter, 5, enter, 2. And now I can do the hit times, and that will be 2 times 5, which gives me 10. And I can say plus, which would be the 7 plus 5 times 2 in parentheses. And it is indeed 17. So yeah, this was a thing. And stack-based calculators. Anyway, I know you were dying to know that information. So that's how this is working so far. And the other one I would want to show you, you know what, let's do this one. Except I need to, because this one has a lot of nested parentheses, but again, you see that it says, give me a float, make it negative, right? Because that's what it's got to do. And now, give me a float of 5 and subtract. Those 4 operations. Now, yes, I know that in the future, we could probably say, you know what, if this is just a float or an integer followed by a negative, we could probably optimize this to just make this 3 a negative 3. And then the fact that we've got a subtract of 2 immediate values of 5 and a negative 3, we could just do that. And so there's a lot of pre-computation that could happen. But those are all optimizations that you would do later. Not yet. Okay. So that's it. We've got, what's the word? Parentheses. We support parentheses now. And I'm going to say get status, get diff. Easy enough. We added the tokens, we added the expression to the grammar, and then we told Flex how to recognize it, and we wrote tests to make sure that they work. Yep. Now, I'm not going to commit this with those those couts. There we go. Now it should run without anything. It does. One more time. Make sure I didn't add anything. I know I didn't, but it's my habit. That's what I do. Which one? Bison, flex, and test. There we go. All right. Now, typecasting. So out of curiosity, how long did that take? We're 20 minutes in and I did a lot of rambling. That's fine. Typecasting. I don't want to support typecasting to just anything. What I mean is user-defined types that haven't been written yet. I think that could be done by functions, but I do want to support the ability to be able to cast an integer as a float, or a float as an integer, or a number as a Boolean, or converting it to a string, perhaps, and maybe not even the string one, but a string as a Boolean, that would make sense. Is it empty or is it not? Once we have arrays, an array as a Boolean, is it empty or not? We don't even have null values yet, but, What will this look like? I think the easiest thing would be to write the test first, which you should do normally, but and let's say I think what do I want this to look like? If I were to say, 3.5 as integer. Again, this is our language. Do I want it to say do I want it to be as int, as integer? As float to me makes sense, but are we going to standardize it with the integer or int? Because we would want to be consistent when we're doing Booleans. Do we want to say bool, B-O-O-L, or have them spell out Boolean? You know what? In my programming, that is, in my C++ code base that I'm writing, I'm spelling out integer. But I think for this, dare I say, customer facing, and what I mean by the end user, I want it to be succinct. And to me, there we go, 3.5 as an int should be a 3. Okay. I would need to... What about converting something to a float? I don't think I need to convert to a float. Well, an integer to a float. I might have to convert something else. Nope, I can see a reason to convert to a float. Okay, so if I have, I'm going to look earlier at our division statements, and we did 3.5 divided by 5. and that gave us 0.7. Okay, so sorry, I got to get back down to it. We had 3.5 divided by 5, but I want this to be an as int, because we already know, you know what? There we go. 3.5 as int. So an integer divided by an integer. Do I want to leave it as that? I want to put a 7 and make this a 2. There we go. And this should be a 7 divided by 2. 7 as an integer divided by a 2. Which should give us a... Corey can't do math. It's a 3. Yeah, that should be right. Now, what about this one? I wanted something as a float. That's what I was thinking of. So I think this is going to be a 0.7, not negative, but a 3 as float divided by 5. Okay, that's just checking it. Now, a 3 divided by 5, if it's as an integer, that was not what I meant to do. That's all right. So 3 divided by 5 as float should also be a 0.7, and that will test our precedence rules, because this as float should convert the 5 to a float. In other words, we don't want it to be I'll just put it here because it's another test. That should give us a different result. 3 divided by 5 should give us 0. Now, all of these are going to... oh, yeah. Typecast. There we go. All of these are failing. That's fine. 1, 2, 3, 4 failed, and I have 5. Why didn't 5 fail? Because I'm checking against 0. That's fine. So let's not check it against 0. Let's check that as 7 divided by 5. Okay, so now I've got 1, 2, 3, 4, 5 failing tests. Good. I'm happy about that. And you say, why did it keep going? The reason is because we have told what's the name of it? Flex to ignore anything it doesn't recognize. And it doesn't recognize as, or int, or float. It doesn't recognize it, so it just ignores it. So all that it understood was 7 divided by 5. And that's why it has a value of 1. And that has a value of 1. But then, well, because it's just seeing an integer divided by an integer. And it's ignoring everything else. All right, so let's start describing these things. We need to edit bison. Yeah, there we go. And so we're going to have a percent token as a percent token int percent token I can't use that. Let's say a cast float. Caps lock was on. And this should be a cast int. I can deal with that, sure. There we go. So so we've described it. We haven't told it how to look for it, but I think at this point we need to have our precedence. So here we go. Our typecasting should be the same as the unary. Yeah, it should. So I'm just going to say as. That should be fine. Should. Like I said, I've not written this before. All right, so let's go back to Flex. And now go down, and we need to tell it when we see the word as, then we are making, an as at that location. And this is going to be when we see int, and this is float, but we called them why did it do that? I'm not sure. Oh, I know why. Cast int cast float. Now this is just when we see it, it's gonna feed it in. Is this doing stuff? Think so. Let's go back to Bison, and I think it's buffer 2. So here we created the tokens as cast int and cast float, and we've given it a precedence. Now we need to give it or explain what the pattern will be. And I think I'm going to do it this way. It's going to be an expression as int. And expression as float. The only problem is we're not now, we need to have some sort of AST node, and that does the conversion for us. And we're going to give it but the at of, so we're passing through the expression, and we should probably give it a name. I think I'm just going to call it, you know what, cast int and cast float, sure. And let's store it as the location of 2. And replace the int with float. Okay. It's going to say I don't know what these are. That's fine for 2 reasons. Number one, we haven't written the include for it, but also we haven't created the AST node types. All right, so let's do that. Let's, we know we're going to need to, is it back? Yeah, to go up. Back, back, back. AST node. Say, Corey, what are you thinking about? I said I was keep being consistent internally. INT-EGER, cast integer, cast float. Okay. There we go. Did I have to put those in order? No, I didn't, but cast integer, cast float. Okay, now it's going to say, hey, I can't find these. I know it can't. So let's just exit this for the moment. And what do I want? I want to in my include, so I've got these AST nodes, integer, modulo. Let's copy AST node integer as AST node cast integer. And cast float as no, I'm not going to do this one yet. I'm going to make all the changes I need to cast integer, and then I'll just change it to cast float. That's fine. AST node cast integer. This is going to be %s, and I'm going to change all caps integer to cast integer. Got that. We're going to do that again for cast integer. Okay, now let's see what we need. So that represents a to an integer. All right, the constructor. It's an expression. So AST node star to be typecast. Expression, and this is the being typecast. That's going to be okay. The indent, the compile, make copy. That all seems correct. So now I'm going to do the same thing for the source. We're going to copy the AST node integer to AST node cast integer.cpp. We're going to cast integer. We'll open that and we will is that everything? Okay. So cast, I'm going to say to integer. But I can't do that. I need to make another line here, and this is going to be indent plus another 2, and then no. It's expression dot dump indent plus. There we go. All right. So cast integer compile. What is it? It is just a new opcode called cast integer. There we go. Now for make copy is we make a new cast integer, but it's going to be this expression make copy. Okay, feels right so far. In the meantime, I'm going to The make file, we know we're going to need these. So AST node cast, I'm trying to keep these in alphabetical order. That's what I need. AST node cast integer.o and cast float, but it should have gone in front of ol.o, and I can fix that. What key do I use? Okay, cast float, cast integer, and now I need to make the .o files for those. AST node. Are these in alphabetical order? I don't think so. Add, subtract, multiply, divide, modulo, float, integer. There we go. And cast float. Cast float. Cast float. There's going to be a cast integer, and cast integer. Okay. That should be right. Oh, because the AST node cast float.cpp does not exist yet, and that is fine because that's what we're going to be making next. So, we're in source, so I'm going to copy AST node cast integer, AST node cast float, fl float.cpp, and AST node cast float, and we are now just going to %s integer float, and just make sure that what am I missing? Cast to float. I need to change the opcode. Cast float. There we go. And I need to do the same thing in the includes. CP, the AST node cast integer to an AST node cast float. I can't spell float evidently, or can't type it. And now vim the AST node cast float, and this one do the same, integer to float, do another one, %s of all caps, integer to all caps, float. And now what do we need? What else do we need? To a float. Okay, so now it's complaining it doesn't have the opcodes. That's fine. We can add the opcodes. So let's say this is pop eval typecast to int push. Should have just done that. Okay. Now, I'm going to have to make that change in both of them. So, expression is I'm looking at the error message over here. The error message is that it doesn't, expression is a pointer, and I used a period. It should be the arrow. So, I don't think, no, I don't have it open. And this is in the CPP file, so I'll just exit out of here. Go back to the main, and now the source AST node cast, I'm going to need to change both of them. So this one here, there we go. And now I need to, in the other buffer, do the exact same thing. And hopefully we should, there we go. It's probably going to give us an infinite loop. Oh, yeah, because we haven't written the opcodes yet. And it would have done an infinite loop before, but we made it give us an error if there's an unrecognized opcode, and that's what we have here. So good, now we need to tell it what to do with those opcodes. We're already in this, we can just edit the source/program. Yeah, let's do the dump bytecode first. And the reason is I'm gonna just steal this one. And this is going to be cast integer. This stupid caps lock keeps on messing me up. Cast integer and there we go. Plus PC. There we go. Okay. And I need more practice with the, so for 85 and 86, substitute integer for float, make it global. There. Did it for just those. Okay, so that's on the dumping, but that's not on the execution, which is what's giving us this error. All right, so let's edit the source program execute. And I need to do a stack check of 1. And this is going to be sure. This doesn't exist yet, but it's about to. All right, and now the float. And so what am I doing here? I am committing right now that I'm going to when we use the arrow operator on the, so the operand is a, first of all, our stack is a vector of garbage collected values. But when we use the arrow, we overrode that so that it gives us access to the computed expression underneath it. And I'm saying now in that computed expression, call a dunder method called int. And that will be our thing to convert it to an int. I'm going to have to write that, so it's about to give me an error as soon as I hit save, that doesn't exist, doesn't know what to do with it. And evidently poop back is not a good thing. Pop back is what it should have been. Yeah, doesn't know what to do with int and float. By the way, we're almost done. Again, we have to write a lot of different parts, but we're almost done. So we're going to edit the source, and this is the computed expression. No, let's do the header first. Include computed expression, and then the source computed expression dot cpp, and then the include for computed expression integer, the source for computed expression integer, and then the header for computed expression float, and then the source for computed expression float. Okay, 6 files. And which one did it open? Open in the first one. Good. So we need to give or define this dunder method. And we've got add, subtract, multiply, divide, modulo, negative. And here we go. And typecast. No, we'll just say perform a typecast to integer. Return the result of the operation. I use that a lot. This is a virtual. It's going to return a garbage collected. And what did we say? This is an int. And it is const. Okay. So we got that. And now let's do the same thing, but with a float. And its name is float. All right. So now it's going to say these don't exist. I can't do the compile because they don't exist. That's fine. We're about to fix that. Yep, they don't exist. So buffer2 and this is garbage collected, and int. Should have been integer. No, I'll leave it as that because that's what the, well, it should be integer. It should be. Yeah. How to cast this value to an integer. And I'll do the same thing. I'm going to have to go back and rename that float. Don't know how to cast this value to float. Okay. Now let's go back to this, and instead of calling it int, we will call it int integer. And now I need to go back and change the program that was under source, program execute, because it's going to try to call int, and that should be integer. Okay. And now I need to do the same thing for oh, yeah. That's interesting. I didn't expect that error. We'll fix that in a moment though. Oh, I know why. For my AST, we'll fix it in just a moment. I know where to fix it. But for right now, cast float, cast integer. And by the way, our error is, it actually did the stuff that it was supposed to. It was, rather than just trying to access the stack that may or may not be there, it actually checked to make sure that there was enough room in the stack, and there wasn't. And so it says, hey, insufficient stack depth. Why? Because we did not tell it to put the thing. Let me just fix that now. Okay. Where would that be? That would be in the AST node. Yeah. So that's in the source node. Edit source. AST node. Both cast float and cast int. See this in the compile. It should have been, I should have done this arrow expression arrow compile and give it the program, right? So it's like if I were to say, 3 as float. I didn't tell it to put the 3 on the stack. I just tried to say as float. So yeah. And now I need to do the same thing for the source. Edit the source for the AST node, and this is cast integer. There we go. And now should be getting error messages. That's what I'm expecting. Don't know how to cast this value to an integer, and then a segmentation fault. Sure, why not? We'll look at that in a moment. Let me get back to what I was doing. What was I doing? That's why I shouldn't chase rabbits. So buffer 3. Oh, yes. So I've got this. Now I need to integer and float. And now it's going to say, hey, these don't exist again. I know. All right. So integer. And the funny thing is if I'm asking for an integer, I can just return star this because I'm already an integer. Cannot convert oh, of course, I need to make a garbage collected based on myself. Yeah. So I can't just return myself because I'm not a garbage collected. I'm a computed expression integer. I don't see a good way around this other than to make a copy. And of course, I don't want to make a copy if I can keep from it. For the moment, you know what? I may add that. No, because I wouldn't. I'm just going to have to do it this way for the moment. Float and float with a using this val. That should be fine. Yeah, it doesn't like it unless I specifically cast it. Okay, I don't have my errors anymore. So let's go back to B3, grab these two lines, and now go to B5. And now B4. Copying some lines and B6. Oh. Yeah. All right, so at this point, this should be float. And I'm going to int 64t. I'm casting myself to that. And then Okay, now let's figure out what the problems are. Because I think I've got all the parts wired up correctly. And yeah, this looks normal. I want to double check the source AST node cast and compile program. Cast float. And do I have the same thing? Yes, I do. Okay, so that should have worked. And so P1, first of all, evidently that worked. And what I'm going to do, I'm going to say P1 dump bytecode inline. Why? Because I know it's going to add its own inline, and I want. So the whole point is that this will show me the bytecode for the 5 different programs. And we'll see if it makes sense. The first one okay, something's not right. You know what? I guarantee you that I'm somewhere along the line when I updated the bytecode stuff that it didn't rebuild. So anytime you get weird stuff, it's worth it just to nuke it all and go back. Why didn't it like that? I'm going back more than once. So let's look at the... this is in Bison. And... I'm going to add the word literal. Literal. There. And do I need to change that here? Nope. Okay. We no longer have our Bison error. Have our segmentation fault again. But let's see. Now we get into the debugging. See, I thought we would be done about now. Hour and 15 minutes in. I may have to hurry through this in order to find it, but that is, I may have to start fast forwarding. I need to look at the time so I can remember it to look back. Do I not have my... in my make file, I don't have -G turned on, so I'm not getting my debug stuff. Just for the moment, let's do that. Still pretty sure I'm going to get a segmentation fault. Okay, that's fine. Rerun GDB. Okay. There, now I've got the line numbers. I was like, why don't I have these? So, expression arrow compile. So, did this not get created correctly? Let's go back to Bison, because that's where it's created. $1. That's the expression. So yeah, now we can see, since I've added the -G, that it has a 3.5 as int. And we're calling compile. And that is, so AST nodecast integer. Maybe I messed up my constructor. Let's look at that. That should be in the source AST node cast integer. Oh, I'm in source. Edit the include for AST node cast integer. So I'm getting this. That'll do it. Let's edit the include for the AST node cast float. If you didn't see what happened, look, I didn't name this variable. And so when it said expression, it just, that's undefined behavior, I believe. Okay, let's get back to this now. So yeah, I quit. Control C. Yes, quit. Oh, I should have said make test. Still a segmentation fault. Oh, wait. Just to make sure. Make clean. Make test. Learn the hard way. Always go back. Looky there. It's working. And it passed. Whoops. Wrong window. All right. We're going to go back to test. I still want to see all of those. Rerun all of our tests. Okay. We've got stuff failing, but it's not... I have to see how long I spent on that so I know how far to jump forward. About 20 minutes. That happens. Let's look at this. So, the first one. 3.5 as int. It pushes on a float that's 3.5 and it casts it to an integer. Yep, and that came out. Oh, and that's the program. Cast it in. And yeah, I want to do that. And for each one of these, that's 1. Wait, this is 2. This is 3. That's 4. And that's 5. Okay. So the first one. 3.5 as int. And it came out correct. The second one. It worked. 7.5 as int divided by 2. So the left hand, it's a divide. The left hand side is a cast to int of 7.5. So 7.5 cast to int, integer 2, divide. That's correct. All right, 3, it failed, but it may be because, well, let's see. It expected 0.6, and I have 0.7. Yeah, I think that the 0.6 is correct. So what? Yeah, what is this? Still a 3. I mean, this is all right. So an integer 3, cast it to float. Integer 5, divide. Yeah. So this is I just got it wrong. That should be 6. And of course, yeah, 3 divided by 5 is definitely 0.6. Okay. The next one. This is 7 divided by 5. 1.4 would be correct, the correct number. But most importantly, you notice the divide, the left-hand side is a 7, and then the 5 is converted to a float. So there's integer 7, integer 5, but cast the 5 to a float, and then do the division. And so, yeah, that should be 1.4. I just didn't write that in. And now, instead of doing it that way, 7 divided by 5 as float, that should be a 1. Why? Because it's an integer 7 divided by an integer 5, which is an integer 1, and then we're casting it to a float. Yeah. And that should be a 1. Now, everything should pass. It's just going to have a lot of stuff dumped out. But that's all right. We can delete that. And now, woo. Okay, I'm thinking, I'll put myself down at the bottom again. I should stop while I'm ahead. But it's working. Now these are only, I guess only, no, I did test both ints and floats. I didn't test casting an int to an int though. Or a float to a float. So let's add these 2 last ones. Say, Corey, I thought you could touch type. I can, except for numbers. As int, and then we'll do 7.5 as float. So this should be a 7, and this should be, nope, that should be a 7, and this should be a 7.5. I can actually touch type most of my numbers. I just can't do it with the 6s and 7s. Don't know why. The reach just never works. And so I'm always second guessing myself. But there we go. We're testing our typecasting. We've got a parenthesis working. Let's just do one last get status, get diff. Does anything stand out? It's wrong. I could do a page down, I suppose, not make you watch the scroll. It all looks right. So I'm going to include AST node cast source AST node cast add typecasting to int and float. All right. Oh, we need to update our documentation. That's the last thing. So didn't I just have that open? Yes, I did. Go back to the main page, and now, for example, in our files, AST node, there's our cast integer and cast float, and in our classes, we'll have those as well, cast integer and cast float. So, yeah. Well, we did it. We got through all of that stuff. And commit -m what episode is it? You know, I never remember that. Episode 17. Yes. For episode 17, get tag-a 017 and -m 017. There it is. It's live. It is on Git right now as we speak. And with that, oh yeah. How are we on our lines of code? We've broken 1,000 lines of C++. 2,000 lines total, and that's not counting all the stuff in documentation, but that's automatically generated. But you know what? I'm very happy with where we've gotten to today. Next, I'm thinking about starting the Boolean operations. I'm trying to decide if I want to make use of the spaceship operator in C++. It's new in C++ 20, and I don't know if it's going to simplify our code or not. We'll have to check. I'm going to do a little bit more reading up on it between now and then. But until then, you know what? Hey, we made great progress. And again, despite the sometimes long hunt for what's wrong, I'm hoping it's been a good experience for you. And having said all of that, thank you. Have a great day. Bye.